I'm going to show you how to do trigonometry in Python. But before I begin, I have to explain to you the unit circle chart. The unit circle chart is used in trigonometry. It's used to describe degrees and radians, sine, cosine, tangent, and their inverses. So I'm first of all going to keep it simple, explain degrees and radians before moving on to the sine, cosine, tangents, and their inverses. So the unit circle goes from 0 degrees to 360 degrees, and it goes from 0 radians to 2 pi radians. And if you look at the unit circle, you'll notice a pattern that's present in the very first quadrant. It goes from 30 degrees to 45 degrees to 60 degrees to 90 degrees. And if you look at all the other quadrants, there's a very similar pattern. Same goes with the radians. You have pi over 6, pi over 4, pi over 3. And these values are repeated very similarly over and over again. Like in quadrant 1 we have pi over 4, and in quadrant 2 we have 3 pi over 4, then in quadrant 3 we have 5 pi over 4, and in quadrant 4 we have 7 pi over 4. So imagine you have the top value of pi, and you just add 2 pi plus pi to get 3 pi, and you just add 2 pi solely to the numerator, yada yada yada. Or look at the pi over 6, it goes from pi over 6 to 5 pi over 6. So plus 4 pi to the numerator. And then you add plus 2 pi plus 4 pi. So for the pi over 6, it's plus 4 pi, plus 2 pi, plus 4 pi. And with pi over 3, there's a similar pattern. It's plus 1 pi, plus 2 pi, plus 1 pi, yada yada yada. Now 2 pi plus 2 pi over 3 would not be 4 pi over 3. What I'm saying is forget the denominator. If you had 2 pi plus 2 pi, you get 4 pi. That's basically what I'm saying, is to ignore the denominator. There's a pattern. If you know it, you know it. So I'm going to show you how to, now as you've probably seen, you have 30 degrees and pi over 6, 5 pi over 4, and 225 degrees. 30 degrees is the same as pi over 6, and 5 pi over 4 radians is the same as 225 degrees. So how do you convert from degrees to radians and radians to degrees? Well, I'm going to show you that. So without further ado, let's officially begin our Python. Part 1. Converting from degrees to radians. Now the first thing I'm going to do is import my math module. Now my module is something in Python. It's a file in Python that stores other mathematical functions needed for it to work. So the first thing I'm going to do is choose the number of degrees. I'm going to choose it to 30. I'm going to set my radians equal to math.radians in parentheses degrees. And I'm going to print radians. And what I get is 0.5 yada 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 radians. So what is happening here? Well, I'm importing or introducing the math module. Now remember, a module is a file that stores mathematical functions. Now right here, I'm choosing the number of degrees. Right here, this line of code uses the formula number of degrees times pi over 180. Now how can I check this using the formula? Well, the number of degrees is 30 times pi over 180. I don't get the exact same thing, but it's close enough. Now another way to check your work is to take this and do it in reverse. Convert from radians to degrees. So we're going to have part 2, converting from radians to degrees. I'm going to import my math module so I can do my mathematical functions. I'm going to choose the number of radians and set it equal to that number. So it's 0.5 235 9877 5598 2988. I'm going to set degrees equal to math dot degrees in parentheses radians, and I'm going to print degrees. And see, I get 29.9999999 and with a 6 at the end, so it's practically 30. And this is basically what we're going to be doing from degrees to radians or radians to degrees. So for review, I'm introducing the math module. I'm choosing the number of radians. Now this line of code uses the formula number of radians, which is this, times 57.2957795. So when you're converting from radians to degrees, you use this formula. When you're converting from degrees to radians, you use this formula. Now let's go check it. We've already... So the number of radians is... I'm going to try to... Okay, I can't copy it, so I'm just going to type 0... Okay, this times 57.2957795. It almost gets me 30. Not exactly the same, but it's close enough. Now for part 3, we're going to convert negative degrees to radians. So once again, we have to import the math module. Import math. Degrees equal to -45. Radians equal math dot degrees in per radians. I got that, I messed up. In parentheses degrees, and we print radians. Now it's the same thing as before, it's just negative now. So if you change it from negative to a positive, what you get is the exact same number, but without the negative in it. So it's kind of the same thing. You're introducing the math module, choosing the number of degrees. This line of code uses the formula number of degrees times pi over 180. So we're going to test this out to check if it's right. So -45 times pi over 180 gets me -0.7. Not quite exactly the same number, but it's close enough. So now we're going to do part 4. Converting negative radians to degrees. So we're going to import the math module. Radians equal, I'm going to have to redo this so it says negative, equal negative 0.785 391 3981 6339 74483. I'm going to set degrees equal to math dot degrees in parentheses radians. I'm going to print degrees. And I get negative 45. Now if we're to change this to a negative to a positive, I would just get 45. And it's the same thing we've been doing. You're introducing the math module so you can use mathematical functions. You're choosing the number of radians, and this line of code uses the formula number of radians times 57.2957795. Now we're going to check this with this formula. So I'm going to use this number times negative 57.2957795. And that shouldn't have been a negative, the negative 57.2957795. But if you ignore that, it would be negative 44.9, so it's almost negative 45. For a more accurate reading, I would use the official radians rather than the ones I got from the calculator, but we're going to ignore that for now. So part 5, converting degrees to radians with large numbers. So we're going to import the math module as always. We're going to set degrees equal to 390. Now where's 390 degrees on the unit circle? Well, the unit circle goes on forever. It goes on forever both with radians and with degrees. It also goes backward negatively. So this is positive, this is negative, and it goes on forever. So you can find the unit circle of negative 10 pi over 3 radians and 1 million degrees radians. It goes on forever, and it's the same thing basically. So I'm going to set radians equal to math dot radians in parentheses degrees, print radians, and I get this number. Once again, we're introducing the math module, choosing the number of degrees, and this line of code uses the formula number of degrees times pi divided by 180. For the rest of this section, I'm not going to write all these notes down because, as you can see, you have plenty of examples. And this is all really the same thing, the same formatting. You're just using it for degrees to radians, radians to degrees, with negative and large and numbers that are on the unit circle officially. So in order to prove this, I'm going to take... I'm not even going to do that. This video is already long, and I don't want to bother you with that. You can also do it with numbers from 0 degrees to 360 degrees, or 0 radians to 2 pi radians that aren't necessarily shown. Like if I wanted to do 10 degrees, I could do that even though it's not on it. Now I'd have to, for radians, I'd have to change my code a little bit for converting from radians to degrees. I should get rid of the with large numbers. I'm doing some of this to save some of your time because I've already done it 5, 6-ish times already. So radians, suppose we want to find 10 radians. So just bear with me. Well, that was a mistake over here. Sorry for my mistakes. So I'm going to show you one more thing in regards to the unit circle before I go into the sines, cosines, tangents, and their inverses. You see how this ends with 11 pi over 6, and how earlier I was mentioning the numerators? So it goes from pi over 6 to 5 pi over 6 to 7 pi over 6 to 11 pi over 6. So ignoring the denominator, 4 pi plus pi equals 5 pi. Ignoring the denominator again, 5 pi plus 2 pi is 7 pi over 6. And ignoring the denominator yet again, 7 pi plus 4 pi is 11 pi over 6. So there's a pattern, 4, 2, 4. So it's going to move over 2 this time. For the final time, ignoring the denominator, 2 pi plus 11 pi is 13 pi over 6. So I'm going to do that here. 13 pi divided by 6 is this amount of radians. And all the degrees and radians have a certain movement, so on and so forth. So the radians will equal, I'm just going to round, no, now I'm not going to, 6.80678408278. So what I just showed you is handy if you want to find officially labeled numbers on the unit circle that are either really far ahead, going on to infinity, or going on to negative infinity, if you know what that means. Now I'm going to move you on to section 2, which is sines, cosines, tangents, and their inverses. So finding sine. So the first thing you're going to do is import the math module. You're going to print math.sine math.radians, and so I should have explained sine and cosine before I started doing the coding. So what is on the y-axis going up is sine, like this 1 over 2, y, negative square root of 3 over 2. Now cosine is the x-axis, like negative 1, 1, square root of 3 over 2, and 1 over 2. As you can see, some of these are negatives and some are positives. So this is like the y values are positive and the x values are positive for the first quadrant. For over here, the x is negative and the y is positive. Down here, it's both negative, and over here, only the y is negative. You've probably seen this before with charts and whatnot. So I'm going to show you how to find radians and cosines. After that, we'll do tangents and inverses. So we're going to first find the sine of 90 degrees, which is 1. The sine of 90 degrees is 1. And this formula is the same for sine, cosines, and tangents. This is once again introducing the math module. And what this is basically doing is just finding sine. So now let's find cosine. It functions exactly the same. So finding cosine. So we're going to import math print math dot cosine dot radians of 270. And now the cosine of 270 is 0. And this might look different, but you see the e to the negative 16th? That means you have to move the decimal to the left 16 times, so it's pretty much 0. So we're now going to move on to finding tangent. So we're going to import the math module. We're going to print math.tangent math.radians. Wait, hold for a second. It was just an interruption, don't worry about it. So tangent is sine over cosine. Suppose we want to find the tangent of 150 degrees, or negative 1/2 over negative square root of 3 over 2. So we're going to find the tangent of 150. Now with the sine and cosine, we can just go to the unit circle and look at the x and y values to see if it's true. Here we have to do the math, so we're going to do negative 1/2 divided by negative square root of 3 over 2. I should have... Wait, let me do that again. Negative 1/2 divided by negative square root of 3 over 2. Please bear with me. I have the right equation, but different calculators you have to type it in differently. So negative 1/2 divided by negative square root of 3 divided by 2. This isn't getting me the right thing. I have the right idea. Let me try to explain it a simpler way. So the negative 1/2, I'm just gonna ask Google this question. Never mind. Never mind about that. I'm just typing this in. That's all. So I have the right number, it just, the calculator can't read my work. You have to type it exactly the same way. So now we're going to be finding inverses. Now an inverse is 1 over sine or 1 over cosine. So we're going to once again import the math module. And we're going to print 1 divided by math.sine math.radians. And I'm going to choose 180. So it's similar, you're just taking the 1 divided by the math. Like look up here, it's print, math.sine, math.radians, and your number. You're just doing 1 over that. And what this gets you, over sine. I think I should choose a better number. So 1 divided by sine, or 1, is 1. So let's choose let's choose 30 degrees. I'm sorry, I was just a little unprepared for this. Forgive my errors, please. So 1 divided by 1 over 2 is 2. And you can also use this for cosine. Cosine of 180. 1 divided by -1 is -1. Or tangent. 1 over the tangent of 150. 1 divided by 0.5. I rounded, but it's kind of similar. And that's, folks, I know this was a bit flawed. I know I was a bit unprepared. Please forgive me. It works out, I trust you. Thank you, and goodbye.